Hey friends, welcome to One Little Coder. In this video, we are going to look at a new project called Daze or also Big Sleep, which is trying to attempt what DALL-E is doing. So DALL-E, if you see, it is more like GPT-3 for images, where you have to just specify a text and then it would create respective images, even the images that do not exist. For example, somebody could simply say that I want an armchair that is in the shape of avocado, and then DALL-E would try to create images that would resemble like that. So there are a lot of such cases, and DALL-E was in use for a lot of reasons. So but DALL-E, the catch with OpenAI is that OpenAI did not open source the model of DALL-E, even though their name is called OpenAI. That's another video altogether. But what OpenAI did is they release details about another model called CLIP. So we have made a separate video about it, which I will link in the description, which you can check it out. So what CLIP does is CLIP actually compares. CLIP creates an image text pair, and then it tries to do a classification and then find out the most similar image. So what Daze does is Daze is trying to create a model what DALL-E could have been. So it is not DALL-E, but if DALL-E is open source, Daze is trying to attempt to create that. So there are two variations to this. Daze is one, and the other one is called Big Sleep. So what Daze does is Daze is on more abstract form. So it is more like the dream form. And Big Sleep is built on GAN, so it is more realistic images. So let's quickly look at these projects and then we'll understand what is happening behind the scene. So first of all, Daze. And before we even get started with the project, I would definitely encourage you to start the repository. This developer has done an amazing job of open sourcing this project. So Phil Wong, so thank you very much for open sourcing this project, and there are a lot of contributors to this. So we should definitely encourage their effort by at least starting their repository, or if there is any other support that we could do for them. So what is Daze? Daze is a neural network, or I should say a combination of neural networks, where if you give a text, that would create a relevant image. So let's see how Daze works. So Daze, if you see, so let me quickly bring you this. So if you see this thing, let me zoom it a bit. So this is the text that you're going to give. So you're going to say that I want mist over green hills, so which doesn't exist, but Daze is trying to create that. So the way Daze is trying to create that is using two neural networks. So one is called CLIP, the second one is called Siren. So Siren takes sinusoidal waves and then it tries to create pixel as an output, and CLIP in this case is trying to find out if that image is relevant to text. So let me quickly show you what is happening. Let me take a pen and then say, first of all, there is an iteration. First iteration, if you say there is an image, so an image, it is generated. Image 1, let me say image 1, and this image is generated by Siren after CLIP says this is the text that I want. So CLIP is going to tell that this is the text I want, and then Siren generates this image. And once this image is ready, now Siren is going to ask CLIP if this image is anywhere close to what you asked. So it's going to say this whatever you said, mist over green hills, that you said, is this image that we generated, the image 1, is it anywhere close to whatever you asked? Now CLIP being something like a classification, so it's going to tell you no, this is not close to what I wanted. So what Siren is going to do is, now Siren is going to create the second iteration of the same image for this text, mist over green hills, and the text comes from CLIP. CLIP tells that how the image should look. Siren creates that image, and then again Siren asks CLIP if this is right or if this is close to what you want. CLIP says no, and then Siren repeats it, and then this goes on and on until CLIP tries to agree, or until the epochs or and the number of training that you have created, and then this is how finally an image like this gets generated that would try to create mist over green hills. Which would ultimately look like that we have given a text and then there is an image generated. So it's more like a combination of NLP and image generation, where all you have to do is give the text in English and then the image is generated. So the other model, the other neural network that we just saw, Big Sleep, it works in the same way, except instead of using Siren, they are using GANs. So GANs to generate the new image. So that is why the images that are generated by Big Sleep, if you see in the example, Big Sleep would look more realistic, because those are images that that are already seen by GANs, but Siren actually creates an image that it has never seen just purely using the instructions from clip. So I hope this was slightly more intuitive for you to understand what is happening behind the scene. So let's quickly go ahead and then see the Google Colab notebook. And this is not something that I created, thanks to the developer and a lot of other supports that the developer has received. So we have got a Google Colab notebook that can actually tell us what's happening. So if I open Google Colab, so there is only one condition, that you have to make sure that the right version of PyTorch is installed. So what the developer is advocating is that first run this Google Colab, first run this cell, and then you have to restart your runtime. Make sure that you have already GPU runtime, and then restart the runtime. And after you restart the runtime, then you have to run the rest of the code. So you can see it is starting to run. While it is starting to run, let's quickly go ahead and then see Big Sleep. So these are the images that are created by Big Sleep. So somebody has mentioned artificial intelligence, it has created this. Somebody has said cosmic love and attention, it has created this. Somebody has said fire in the sky, and you have seen this. And if you see the images in Deep Daze, it is more on abstract form. So it is not like, something that you would see in real life, but it is more like on an abstract level. So it's more like, art. So now the model is getting downloaded. The PyTorch, the right version of PyTorch for this project is getting installed. And after it gets installed, we have to restart the runtime. And after we restart the runtime, we will see how this project works. So if you want to run it, if you have got your own GPU and if you want to run it, I think you probably need at least 16 gigs of memory for you to even work on it. So that is what we are using Google Colab for. So all you have to do is pip install Deep Daze or pip install Big Sleep, and then you have the package installed. So there are two ways you can invoke the package. Either you can use the CLI command on command or terminal bash shell. You can just give the name dream or imagine, and then you can just give the text, or you can use it as part of your Python code. So however you want, you can actually do it, and it comes with a certain set of attributes which are available as parameters on the Google Colab notebook. So it's installing the existing Torch version, and then it is installing the new PyTorch version, and it is still happening. So one thing that I would like to highlight is that when I was running this before making this video, it took quite a lot of time, So I'll make few changes here before I even start running this, and then also I'm not going to run it completely. I'll probably tell you what is happening or what is the situation here when we actually run this thing. But this is definitely a great open source project, especially given the fact that the company that is calling itself OpenAI did not open source the model that has gained all the news. So this is happening very well, and thanks to the developers of Lucid Drains, Phil Wong, and the team, the other developers who made it possible. So it has successfully installed the Torch version, and then it is installed. So now that this is changed, now let's say restart the runtime. Yes, cool, restarted. So you can see that it is getting restarted, and it is successfully restarted. Now you have to install the package, pip install Deep Daze. So it is installing the package. Package installation is successfully done. So like I said, there are two ways you can invoke it. So you can either simply say that imagine, and say a dog with a tiger face. I know it's a very terrible thing to ask, but let me just quickly show you that you can see that it has started running. So our package is installed successfully, and it has started running successfully. It's not going to probably show you anything like how you run it on a Colab model. So I just wanted to highlight this, that this is possible. So probably I would switch it off at this point, and then I would go ahead with the Python version. Let me stop it. Stop. Okay, so I think my relation with Google Colab is terrible, or my patience with the cell execution is terrible. Okay, successfully I've stopped. So now let's come to this part, and again thanks to the developer or whoever created this thing. So they've made parameters, which means it's easier for anyone to start with. You really do not need, and if you see the API, it's very very easy. So all you have to do is you have to import deep days, and then from that you have to import imagine. You need an input text, which is what the clip is going to use to create the model, and then you have to specify parameters like number of layers you want to use. On all these parameters primarily depend on only one thing, your computer's memory that you have got, your GPU's memory that you have got, your machine's memory, and also how much of accurate or good image that you want. So there are a lot of things that we would change. I'll quickly show you, and then you have to just pass on all the attributes, parameters that you just defined, and then you pass it on to imagine. That's it. Your model is going to train, and while you're training the model, you can probably show the image at every iteration, and that's what they're going to do here. So at a point they will show the latest image that has been generated by the neural network. So these are the attributes. First you need to give the text. Second, number of layers. 32 is slightly too much for you to do it on Colab, so it might take more time if you want to do it on Colab. So it is better, sorry, it is better okay, I'm messing up with my machine. Okay, yeah, so it is probably not good, so we'll change it to 16. And then if you want to save it after every 20 or 200, like it's up to you. Let me show 100. And image width also plays an important role in if you do not have enough memory. I think by default you get a 16 gig machine from Google Colab, so you can so because of that not Pro, normal Google Colab, so you can reduce the image width. Learning rate, again, if you reduce the learning rate, because the image is an abstract image, it would go very terrible, so I would probably leave it as it is. And the number of iterations you want to run, I'm not going to change it a lot, so I'll just leave it as it is, and then let's run it. Oh, sorry, let me quickly stop it. What we are trying to run is I don't want to restart the runtime. Okay, or probably I should leave it. So I was planning to give a dog with a tiger face as an input, but it's okay. Let's look for an apple next to a fireplace. So this is how it looks at this point. Let me see if I can run it and see a dog with a tiger face. Probably that would be it would we might appreciate the model well if we actually look at the, let me give a dog with a tiger face, and then let's run this. It's getting executed. So I definitely want all of us to appreciate the kind of work that has gone into this particular creation of neural network, whether it is deep days or a big sleep. We can have a look at big sleep, but I don't think it is actually required. It basically it works very similar to whatever we saw there. So you can see the generated images, temporary images that are already generated. So it's running, still running. So this is the old image that we had, so it would probably show the new image. And because we said save after every 100, so we still have not hit 100, so it would show us after 100. It's actually happening faster because we have changed 256, and if you go below 256 it wouldn't look good. And also we are using only 16 layers, not 100 layers, sorry, not 32 layers. So now you can see that the image is saved, so you can see how the model has worked. So it looks like dog, but also it has some kind of tiger pattern. I am not definitely saying that this is the best output of this, but we are far away from getting the best output of this, given that we want to run it for 1050 iterations, and we are just in the first iteration and 100th iteration. So I wouldn't say anything bad definitely about this neural network and then the kind of effort that it has put together. So let's look at one more variation of this image, and then we can probably wind it up there. Let's look at the image. So the image is getting on improved, so it is continuously improving, and like I said, it is definitely a great thing this developers have done. So let me stop it instead of unnecessarily using Google Colab's computation power. So once again, you have the sample Colab notebook for both Big Sleep and also Deep Daze, so you can check it out both. So this is the only prerequisite. If you see, install the right version of PyTorch, restart your runtime, and then go ahead. So there are ample opportunities for people to use this and create whatever they would like to do. I would definitely be so happy if OpenAI lives up to its name and then open sources the image, the model that is used. But again, thanks to the community that has actually created something that looks similar to DALL-E, and they have also open sourced it. So thanks to the developers who were the contributors, in this case Lucid Reigns, Dayan, Rexlo, and for Big Sleep, if you see Phil Wong and Enrico Rose, and also they have mentioned another name which I would like to give a shout out for simplifying the Google Colab notebook, which is Ryan. So Ryan Murdoch. So all these people, thank you so much for making open source an awesome place, open source community an awesome place, and giving this. So like we discussed, this model, especially Deep Daze, uses Clip and Siren, and Clip tells Siren how to generate the image, and then Clip also validates the generated image, and then this iteration goes on until Clip gets satisfied with the image that you have generated. And in case of Big Sleep, it uses Big GAN as an input. So that is the only difference. And if you have not used Clip before, so I would definitely recommend you to check my other video about zero shot text classification, zero shot image classification using Clip. And Clip is actually wonderful, and then that Google Colab notebook is also available for you to try it out. I hope this video was helpful in understanding something great is happening in the text and in the intersection of both text and computer vision image. So if you have any comments, please let me know in the comment section. Otherwise, I would encourage you to subscribe and share the word about this channel. That would mean a lot to me. And until next video, please stay safe and take care of yourself. See you.